So next we're going to look at the process of composting, and you can see the definition is posted here. Organic material that has been decomposed under controlled aerobic conditions is compost. So let's start with the words organic material. The materials that we can compost include vegetable scraps, fruit scraps like an apple core, coffee grounds, grass clippings, leaves, all of these types of things. The only thing we can't put into composting material is dairy or meat products because of the fact that animals are attracted to that. However, all of these other organic materials can be contributed to your compost pile. And then you see it says decomposed, which means they break down into smaller and smaller products of organic material. So you might start with eggs look like this, but by the time your composting is done, it looks like that. And it says under controlled aerobic conditions. Aerobic means with oxygen. Remember, anaerobic means without oxygen. So here you have bacteria, or it can be worms as well, that can break down this waste material and turn it into broken down organic material that can be then used by other organisms, particularly plants. So the benefits of doing this is that it certainly takes up less landfill space that it would take it up unnecessarily. And landfills produce CH4, as I've mentioned, methane. So the more you have the anaerobic decomposition of materials such as this, the more methane is produced. Whereas when you have aerobic decomposition of the material, methane is not released. So all it takes is some type of open composting pile and a little pitchfork to stir it around so that it can more evenly decompose, and a little time, about 2 to 3 months. And I have a video clip for you posted on Moodle. It's a very funny little clip from a gardener that was doing a TED Talk and explains how you can compost at home quite easily. There are also larger scale operations. For example, the town of Barnstable has one where you can bring, weed trees that you cut down and things like that you don't want to put in your compost pile. You can pay a small fee and drop it off there, and they turn it into compost. So that was your 3 R's in composting, but unfortunately most waste is not recycled or composted. So next we're going to take a look at how it's treated when it goes into a landfill or it's incinerated. So first, some definitions. A dump. A dump is a hole in the ground into which solid waste is placed. You would not find a true dump in the United States anymore, but you would find them in other countries, particularly developing countries. Now we have landfills. It's also a hole in the ground, but it's constructed so that pollutants in the waste don't ever come into contact with the soil or groundwater. So they're lined. So that they're either lined with clay, which is very dense, or certain types of materials such as plastics or rubber to keep the waste separated from the ground underneath and then eventually the groundwater. They have a leachate collection system, which I'll show you in the next slide, so that as it rains and the rain comes down and works its way through the waste, that liquid material is collected and cleaned and not just released into the environment. They also have methane vents to vent the methane that is produced from the anaerobic decomposition of waste. And nowadays, some of those methane vents are actually changed into collection systems to collect the methane for energy use. And when a landfill is done, it's typically capped over and so just covered with soil and a liner to protect more rain from entering into that system. and often that land can be used for things like placing solar panels down. And the third process by which waste can be treated is incineration, which means burning. And in the case of Massachusetts or Cape Cod and the nearby areas, nearby towns, we burn our trash, combining it with electricity generation at a plant called CMAS, which I will also show you in a minute. This figure shows you how composted material can be composted on a large scale, in a large scale operation. So here you see a dump truck delivering waste such as newspaper, leaves, grass, food scraps, and sometimes woody material. And then the materials are separated out so that no non-compostable materials go into the system. And then the non-compostable material is removed to a landfill, and the compostable material is aerated, so oxygen is introduced, and turned one or more times to speed up aerobic respiration of bacteria for a period of 30 days to 1 year. And then it's allowed to cure or dry, and then finished compost is ready to be transported for use, for sale. Now here we have a diagram or a figure of landfills, and the way it works, let's just take a look at the cycle here first, and we'll look at these other words later. So solid waste is transported to a landfill. In the case it's usually carried in garbage trucks. And then when it fills into this very large hole that's dug in the ground, and it's compacted to fit as much solid waste in there as possible. But since it's compacted, there's no oxygen. That oxygen is going to be squeezed out of there and depleted. And you can see that it is lined with a protective liner that prevents any water and any pollutants that get in here from going into the ground and eventually into an aquifer. You can see the third feature here, which is a leachate collection system. It removes the water that has come down from the rainfall that's percolated through and carries them to a wastewater treatment plant where they're treated and then the water's released. At the end of the useful life of a landfill, it is capped and it's covered with a protectant layer and soil and then planted vegetation. And you can see here a little diagram. I think that's supposed to be the methane vent. Whoops, coming up here. Those little, silver aluminum vents that you typically see on the tops of these. And that's the methane extraction system, releasing the methane or collecting the methane. You can see also that groundwater is typically monitored carefully next to a landfill, because if there was a leak here, you'd want to know that it didn't get into your drinking water. So why do we use landfills instead of some of the other technology that we'll look at in a minute? Well, it's really inexpensive comparatively, about $35 a ton for a tipping fee. That means for the fee for tipping the dump truck with the trash into the dump. That's about half what it will cost for taking your trash to a trash-to-energy plant. The leachate, again, I think I've already described that. It's collected and removed. Archaeology, what I wanted to mention there is that an archaeologist did a sampling where he dug into landfills and extracted what was in the waste and found that there was newspaper in there, that the print could still be read after about 35-40 years has passed. So you would think newspaper would decompose pretty readily, right? But in this type of anaerobic situation, it will not. So now let's look at incineration. So the waste materials, the solid waste, is burned, which reduces the volume that needs to be taken to a landfill. and it can also be burned in order to generate electricity and heat. The tipping fee is approximately twice what it costs to put in a landfill. There are air pollution issues that need to be monitored, and they are. There is still the ash, which needs to be buried. There is still this NIMBY, or not in my backyard issue, which I'll talk about in a minute, and then I'll talk about our CMAS plant. So in a typical situation for incineration, the waste in our case is brought either by truck or by the 6A train, trash train, and it's dumped into a refuse bunker. And then you have the crane, well, actually in the CMAS plant, they separate out all of the materials that are not going to be burned. And that's done on these giant moving belts, and it's actually done by magnets and by hand, people monitoring the belts as the trash comes through. And then once we have just material that can be burned, that goes into a hopper, and it's burned in an incineration chamber. And not shown here, but the incineration can heat water and turn a turbine, just as we've seen with those other sources of turbine energy creation, and that can create electricity. At the end, there is an ash bunker. I went to the plant in CMAS, and it was pretty incredible. The ash bunker was kind of like a giant, super giant fireplace. It smelled like a fireplace, and it had ash in there like a fireplace. And that was simply removed and placed in a landfill. Next, we have the fact that when you incinerate the trash, air pollution could be an issue, but a baghouse filter that we've talked about before is the typical ways of cleaning the air before it's released through a chimney. In a plant like CMAS, they monitor a lot more of the air before it's released into the environment, and they do a very good job of that. Okay, to NIMBY, not my backyard issues. Where do you place an incineration plant, or where do you place even especially a dump, a landfill, I should say. So you want it to be close enough to your population that you don't have trucks or trains carrying trash a long distance. But you don't want it so close that it could contribute a problem to either your air or your aquifer or other groundwater. So oftentimes, unfortunately, landfills in particular are placed in areas, in neighborhoods that contain folks from lower socioeconomic groups are living. And that would be an example of something that's not acceptable that environmental justice would step in to rectify. So the NIMBY, or not in my backyard issues, occur with both landfills and incineration. And it's not just an issue in the United States, where there have been studies which demonstrate that these landfills are often placed in lower neighborhoods that are inhabited by folks of lower socioeconomic groups. And globally, it's even a worse problem. Not just a problem in the United States, it is a global issue. Okay, some other quick issues about incinerating. Let's see, I already said reduced volume of waste can be used to generate electricity. Those are both good, but it can release air pollutants, though these are removed by filters, particularly in places like the United States. The ash may still contain some toxic chemicals and must be disposed of, and as I already mentioned, they're, more expensive than landfills. Okay, I only have 15 seconds on this, so I'm going to stop here and come back.